This video will help you determine the electronic configuration of elements with proton number 1 to 20. At a later stage in the series, we'll be looking at the electronic configuration of ions. By the end, you'll need to be able to state that group 8 noble gases have a full outer shell, that the number of outer shell electrons is equal to the group number in groups 1 to 7, and that the number of occupied electron shells is equal to the period number. The scientist Niels Ball was the first person to put forward the idea of electron shells as a model for how electrons are arranged in the atom. He was a Danish physicist who made foundational contributions to understanding atomic structure and quantum theory, for which he received a Nobel Prize in Physics in 1922. Ball was also a philosopher and a promoter of scientific research. He died in 1962. Now, electrons are arranged in shells around the nucleus, and the first shell closest to the nucleus is the lowest energy level. The further a shell is from the nucleus, the higher the energy level. Now, each shell can hold only a certain number of electrons, and these are the rules. The first shell can only hold 2 electrons and fills first. The second shell can hold 8 electrons and fills next. The third shell can hold 18 electrons, but it fills up to 8. The next 2 go into the fourth shell, which are not shown in the diagram. Then the rest of the third shell fills. Here are the electron shells for the first 20 elements of the periodic table. The number of electrons increases by 1 each time. It's the same as the proton number. The shells fill according to the rules covered in the previous slide. Now remember, the third shell can hold 18 electrons, but it fills up to 8. And the next 2 go into the fourth shell. Then the rest of the third shell fills. But you don't need to worry about that at GCSE because it's not covered. Use these shortcuts to help you draw electron shells for the first 20 elements very quickly. The period number tells you how many shells there are, so look at the period that the element is in and draw that many shells. All the elements in the group have the same number of electrons in their outer shell. So if you know something is, say for example in group 6, it has 6 electrons in the outer shell. The group number is the same as the number of outer shell electrons, which are also called the valency electrons. Now, the valency electrons dictate how an element reacts. So the elements in group 1 all have similar reactions, for example. Here are the electron arrangements for lithium, sodium, and potassium. Now notice that they've all got 1 electron on the outer shell. All 3 react with water to give an alkaline solution, and all 3 metals react in a similar way because their atoms all have 1 outer electron. The elements in group 8 have a very stable arrangement of electrons. Their atoms all have 8 outer shell electrons, except for helium, which has 2 as it only has 1 shell. Group 8 is sometimes known as group 0. The stable arrangement of electrons has a very important result. It actually makes the group 8 elements unreactive. Another word for unreactive is inert. Here are a couple of facts for you to take away. Now remember, all isotopes of an element have the same number of valency electrons, so their chemical reactions are the same. Isotopes all have the same electron shell arrangements. Electron arrangement, electron distribution, electronic structure, electronic configuration, whatever you call it, these terms all mean the same, how the electrons are arranged in shells.